Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0797 indicates an issue with the CVT, continuously variable transmission, clutch pressure control solenoid valve, C, being stuck in the on position. This specific solenoid plays a critical role by regulating hydraulic pressure that engages the forward clutch and reverse brake. When functioning correctly, the solenoid adjusts the valve position based on electrical signals from the powertrain control module, PCM. A failure in this system will cause improper hydraulic engagement, leading to transmission performance issues. In Honda Accords from 2012 to 2017, equipped with the K24W1 engine, this DTC can trigger warnings such as a blinking AT, automatic transmission gear position indicator, indicating a malfunction. This DTC sets under specific driving conditions and is crucial for identifying issues with the vehicle's transmission system. After completing the troubleshooting process for DTC P0797, the final step is to verify that all repairs made address the malfunction. Technicians should use a scan tool to clear any DTCs and return the system to its normal operation mode. Following the clearing process, it is crucial to conduct a test drive to confirm that the AT gear position indicator behaves normally and no malfunctions reappear. Monitoring the vehicle's performance after repairs ensures that the solenoid is functioning correctly and confirms that hydraulic pressure regulation is effective, preventing errors. Continual observation during various driving conditions helps assure that the issue has been resolved. It is only after verifying this operation can the repair be considered complete, ensuring the vehicle is safe for normal use. To prevent future occurrences of DTC P0797, it is vital to perform regular maintenance on the vehicle's CVT system. Routine changes of the CVT fluid ensure that contaminants do not hinder the operation of the solenoid and maintain optimal hydraulic performance. Additionally, regular inspection of the solenoid wiring and connections can help identify potential electrical issues that may interfere with solenoid function. Keeping the electrical connectors clean and secure prevents disruptions in communication between the PCM and the valve. Implementing these preventive actions not only helps avoid operational problems, but also extends the life of the transmission system. A proactive approach to maintenance can mitigate the risk of unexpected failures and enhance overall vehicle reliability. In summary, understanding DTC P0797 revolves around the function and role of the CVT clutch pressure control solenoid valve. This component is critical for maintaining proper hydraulic control within the transmission system of Honda Accord models from 2012 to 2017. Following the provided troubleshooting steps meticulously assists technicians in identifying the root cause of the malfunction. Future maintenance practices, such as regular CVT fluid changes and wiring inspections, can greatly reduce the risk of encountering this DTC again. Ultimately, timely and effective diagnosis not only resolves immediate performance issues, but also contributes to the longevity of vehicle components. Through proactive maintenance and thorough troubleshooting, drivers can ensure their Honda Accord remains reliable and efficient. The CVT clutch pressure control solenoid valve is an essential component of the vehicle's transmission system. It controls the hydraulic pressure necessary for the forward clutch and the reverse brake by opening and closing in response to signals from the PCM. Located within the transmission assembly, this valve ensures proper engagement through a duty cycle output. The valve spool adjusts its position based on the current, allowing for a proportional hydraulic pressure response. When functioning properly, the solenoid will facilitate smooth transitions between gears. However, a stuck-on condition can be caused by electrical failures, contaminated fluid, or physical blockage within the valve, leading to a prematurely engaged clutch that can produce erratic or harsh driving experiences. Understanding the possible causes for DTC P0797 is vital in determining the appropriate repairs. The primary cause is a stuck CVT clutch pressure control solenoid valve, which can occur due to mechanical failures or debris in the valve. A faulty signal from the PCM can also result in the solenoid being continuously engaged, which affects hydraulic pressure control. Additionally, fluid contamination can impact the operation of the solenoid, potentially leading to sticking or binding. Other issues might include wiring problems or electrical connectors that could disrupt the signals sent to the solenoid. Since these causes may lead to significant transmission problems, it is crucial to address them promptly to ensure reliable vehicle performance. Symptoms associated with DTC P0797 can significantly affect the driving experience of the Honda Accord. One common symptom is noticeable transmission performance issues, where the vehicle may exhibit slipping or erratic engagement. Alongside this, drivers may see the AT gear position indicator blinking, indicating that the vehicle's transmission control is experiencing a fault. Another symptom includes harsh shifting conditions, especially when transitioning from neutral to drive. As a result, the vehicle may jerk or lurch unexpectedly, impacting overall ride comfort. These symptoms are critical indicators that highlight an underlying issue with the CVT system, and timely diagnosis is essential to prevent further damage. In the first step of troubleshooting DTC P0797, the initial action involves starting the engine to engage the vehicle's electrical systems. Once the engine is running, the brake pedal should be firmly pressed to ensure safety while performing the subsequent tests. Maintaining pressure on the brake pedal is essential as it prevents the vehicle from moving unintentionally. This foundational step sets the stage for observing the operation of the CVT system under controlled conditions. Once these steps are completed, mechanics are better equipped to evaluate the solenoid's performance and identify whether a malfunction persists. The second troubleshooting step requires the technician to move the shift lever from the neutral N position to the drive, holding it in drive for roughly 2 seconds. This action simulates a standard driving condition where the vehicle transitions from being stationary to moving forward. The 2 seconds of waiting time is critical, as it provides a moment for the PCM to evaluate the solenoid's response and for the hydraulic pressure to stabilize. By allowing this fixed time frame, any immediate response from the solenoid can be effectively monitored. After this position change, the technician can assess whether the solenoid engages correctly or remains stuck in the on position. In this third step, the process requires repeating the action of shifting the lever from neutral, N, to drive D, and waiting for 2 seconds 5 times. This repetition allows the PCM to gather sufficient data regarding the solenoid's performance under various shifting patterns. This driving pattern effectively mimics real-world driving scenarios, enabling the PCM to detect any inconsistencies in performance across multiple cycles. If the solenoid responds properly throughout this procedure, it could indicate that the issue may not be persistent. However, if the malfunction remains evident, it reinforces that the solenoid might be the source of the problem, necessitating further inspection or replacement. The fourth troubleshooting step focuses on turning the ignition switch to the lock 0 position, or using the engine's start-stop button to select the off mode. This action effectively resets the vehicle's electrical systems, allowing for a new evaluation cycle. By cutting power to the system, it forces any stored codes, such as the pending DTC or confirmed DTC, to be cleared from immediate memory. This is essential when diagnosing multiple concerns, as it allows technicians to see if the problem is transient or persistent. Following this step, it is crucial to observe any changes in indicator light behavior, which can signal whether the issue remains unresolved. After resetting the ignition system, the technician is required to repeat the driving pattern steps 1 through 3 again. This second evaluation will help confirm whether the CVT clutch pressure control solenoid valve still exhibits a stuck-on condition. By conducting these tests, mechanics can assess if the original symptoms persist or if they are able to replicate the operational issues encountered earlier. A consistent result throughout each cycle can indicate a malfunctioning solenoid or potential fault within the electrical connections leading to it. Noting any discrepancies during repeated observations is vital for a thorough diagnosis. This approach emphasizes methodical evaluation to ensure an accurate determination of the root cause. Please like and subscribe to the channel. See you next time.